So hi, good day. Well, morning actually. Amid all the COVID situation, and schools being closed, doesn't stop learning from happening, right? So we have chemistry today. As you can see in the name of the live view, we have chemistry. So today we want to go through moles and equations. I know a lot of people, from my experience, had a lot of issues with moles for some reason. And moles is not really something that's hard. But then again, at the same time, to be able to properly do moles, you have to properly be able to balance the equations. So I do hope that you practice your balancing equations, you understand how to balance equations, etc. So before we get into it, a couple things we're going to cover in this class session today. So, just want to welcome you all again to E2TT. Follow us on Instagram, Facebook, Twitter for your updates. Feel free to join other classes upcoming, and let's make this a productive one. Don't let the virus get us down. We still have to pass. We still have to get them qualifications, because life would eventually go back to being normal eventually at some point in time. So let's look to get into it, right? So today we'll be covering moles and equations. So feel free to ask any questions in the comments down below, or to the side. I believe it's to the side. Please feel free to leave your comments there. So let's go. If you have audio issues, feel free to turn up your volume. So let's get going. So moles and equations. Sorry, my bad. Moles and equations, not moles. Right, moles and equations. So, moles, let's go. So the mole is based on Avogadro's constant, which the mole is the mass of a substance containing the same number of fundamental units as there are atoms in exactly 12 grams of carbon 12. Now what that basically saying is they're equating it to carbon 12, which they are positive that they have 12 grams of, and it equals to 1 unit because it's carbon 12, right? So 1 molar unit. So I'm going to just put the definition up there for you all to see. So, yes. So basically, that's what a mole is. And, hold on, let me just insert that there. Text box. So you can take note of that. The mass of a substance containing the same number of fundamental units as there are atoms in exactly 12 grams of carbon 12. It's a subscript. A superscript. Right. So that's what a mole is basically. So what we want to move on to. So the mole is the unit representing this amount of atoms, ions, or molecules. 1 mole is the amount of a substance that contains 6.02 by 10 to the 23rd particles, atoms, molecules, or formulae of a substance, which is also known as Avogadro's number. So I'll put that up for you to take a definition note of that. So that's what Avogadro's number is. Right? Cool. Now, let's move along, shall we? So for example, 1 mole of sodium contains 6.02 by 10 to the 23rd atoms of sodium. Right? So that's basically using Avogadro's constant to show how much 1 mole of sodium contains, how much particles it contains. And then we have 1 mole of hydrogen, H2, contains 6.02 by 10 to the 23rd molecules of hydrogen, because hydrogen doesn't exist by itself as a single atom. It moves as a molecule because that's what hydrogen is. They're covalently bonded, so they're molecules. And then 1 mole of sodium chloride chloride contains 6.02 by 10 to the 23rd formula units of sodium chloride. So this is what it looks like. Right? So let's recap that quickly so you have an understanding of what's happening here. So again, let's recap. The mole is the mass of a substance containing the same number of fundamental units as their atoms in exactly 12 grams of carbon-12. 1 mole is the same amount of a substance that contains 6.02 by 10 to the 23rd particles, whether it be atoms, molecules, formula units of a substance, which is also known as Avogadro's number, because this is Avogadro's law. And the examples, as you can see, as it correlates to Avogadro's number, 1 mole of a sodium contains 6.02 by 10 to the 23rd formula units, atoms of sodium, right? Just fix this here because this should not be. Just fix these. These should be superscripts. Right, much better. So what that tells you is that's how much particles it contains in 1 mole of that substance. So that's a lot of particles. Any questions so far? Yes? No? Feel free to leave it down below. Or to the side. So let's move along. If we have an understanding of what was just said, we could move along to the meat of the substances here. So moles and Avogadro's constant. Linking the mole and the atomic mass. So 1 mole of any element is equal to the relative atomic mass, or RMM, of that element in grams. For example, 1 mole of carbon, that is, if you had 6.02 by 10 to the 23rd atoms of carbon in your hand, it would have a mass of 12 grams. Now, why did I say 12 grams? Because carbon is 12 on the periodic table. And what they're saying in 1 mole is equals to 12 of carbon 12. 12 grams of carbon 12 is equal to 1 mole. Right? So 1 mole of helium atom would have a mass of 4 grams, and lithium 7 grams, etc. So for a compound, we add up the relative molar atomic masses. because carbon is 6th in the periodic table, right? So it will have a mass of 12, which you know how you get mass. Protons carry a mass, and neutrons carry a mass, which is in the center of the atom. The electrons have no mass. So 1 mole of water would have a mass of 2 by 1, because the mass of hydrogen is 1, and it has 2 hydrogen atoms, plus 16 because the mass of oxygen is 16, which gives us 18 grams. So let me just show you that. Right? So, as I was saying, you add up the relative molar masses to get the mass. But it doesn't stop there. That's the first step. Like I said before, you can follow us on Facebook and Instagram and WhatsApp to join one-on-one online classes as well, and a variety of subjects. So let's move along. Right, so, and then we have the mole and the volume of gas. Now when it comes to the volume of gas, it's done a little different, just a little, and we measure this in dm cube. Okay, so the molar mass, the molar volume, this is the volume that 1 mole of any gas, be it molecular such as carbon dioxide or monoatomic such as helium, will occupy. Its value is 24 dm cube or 24,000 cm cube at room temperature and pressure. So you always put at RTP. So you have the gases and how much space they occupy. So we could state that each gas occupies a different amount. Let's say, for example, the equation calculated is the amount of gas in moles equals volume of gas in dm cube divided by 24. By the way, this dm cube is decimeters, if you wanted to know. Right? And let's move along. This is an error. This is in centimeters. So this is basically what you'll be seeing here. So as I said, if 1 mole or whether it be molecular or monatomic occupies 24 dm cube at room temperature or pressure. So that's how you'll work out how much moles. So you get here to find the moles of gas, you have the volume of gas divided by 24 if it's already in dm cube, or 24,000 if it's already in cm cube. So let's do a little calculations now. Just put this to the side, and we do a little calculations here. So let's calculate the volume of gas of methane. So we have, let's see, we have methane, which is CH4. Now, let's say the volume of methane gas we have is 200 and let's see, 225.2 dm cube, right? Now the equation says volume of gas, to find the moles, just moles equals, it's already in dm cube, so we calculate it like this, multiply, let's say multiplied by, not multiply, sorry, divided by 24, which works out to be, let's see, 225.2 divided by 24, and we get 9.383 moles, right? So we just worked out how much moles that methane occupies, right? So you can see that. So you have 225.2 dm cube of methane. To find the moles, you divide by 24 and you get this answer here. Let's do another. Let's do one for chlorine gas. So we have Cl2 equals, let's say 320 dm cube. So as the law says again, this is at RTP as well. As the law says, to find the moles, you just divide that by 24. So you have 320 dm cube or slash. And let's see how much that works out to be. And we get 13.333 moles. Right? So that's how much volume of gas chlorine is occupying. How much moles of chlorine occupies. If you have any further questions, feel free to ask along the way. Just remember, subscribe to the YouTube page, and then we have follow the Facebook, follow the Twitter. Right? Cool. So let's move along again. Let's do our next example. Let's do one for oxygen. So we have O2. It's occupying 1200 cm cube. So let's find moles. Since this is already in cm cube, what we're going to do this time is we have to work it. We can either convert it to dm cube and then work it, or work it as cm cube as well. Divided by 24,000, because that's how much cm cube is in 24 dm cube. And what we will end up with is, let's see, 1200 divided by 24. We cross these two zeros off, cross these two zeros off. And then we're left with, let's see, 0.05 moles. So that's how much moles of oxygen occupies 1200 cm cube. That's how much moles in it. Right, so we have that and we can move along now. Just remember, this is only at RTP, room temperature and pressure. Also, the value is usually in dm cube. We work in dm cube, we can convert to dm cube, or when working at cm cube, make sure all values match. Right, so we have 24 dm cube, and that's how we work it out. The volume of the gas divided by 24 dm cube or 24,000 cm cube, depending if you're working on cm cube or dm cube. Let's move on. So we're moving on to calculating reacting masses, solutions, and concentrations of solutions in grams per dm cube or moles per dm cube. So please note of the formula triangle for moles, mass, and formula unit mass. Just should draw this bigger. Let's go. So we have the mass, we have moles, and we have relative molar mass. Right? That's what we have there. So the mass is usually in grams. Moles, number of moles. And mass of 1 mole. So let's study this triangle for a second. And it's just being able to manipulate this formula, right? So to be able to calculate moles, now keep this triangle in mind. Let's be able to calculate moles now. So to be able to calculate moles, moles is equal to the mass of the substance in grams divided by the molar mass, the relative molar mass. Right, yeah. So that's cool. We're going to work out some equations of moles now. Right, so this is the equation. I'm going to put it up so you can follow. Let's go. What's happening here? So this is the equation here. Moles equal amount of moles equals mass of substance in grams divided by molar mass, or RMM. Right? So let's do some examples. Let's do one for sodium hydroxide. So we have sodium hydroxide, NaOH. The RMM for this is RMM equals 23 plus 16 plus 1. Usually this is given to you to be able to count it up. I give you the individual amount for each element. So sodium is 23, oxygen is 16, and hydrogen is 1. Let's say the grams, the mass, small m, equals, let me say, we have 80 grams. Sorry for the bad writing, kind of hard. But yes, we have 80 grams. This is equal to 40. Now, as the formula says, moles equals to mass of the substance in grams, which is 80, divided by the molar mass, which is 40, and that is equal to 2 moles. Right, so that's 2 moles. So, again, let's recap this. We found the molar mass, which is 23 plus 16 plus 1, which gave us 40. They give us the mass of the substance as 80 grams. We divide the 80 by the 40, and we end up with 2 moles, just like that, in that order. Now we do another one. I don't feel like getting this thing yet. So we try this again. Let's do one for calcium carbonate. So we have calcium carbonate, CaCO3. So let's work with the RMM. RMM equals, we have 40 for calcium plus 12 for carbon plus, in brackets, 16 for oxygen by 3, because we have 3 oxygens. Right, so 60 by 3 is 48. 48 plus 12 is 60. 60 plus 40 is 100. RMM does not have any units attached to it. So grams, so little m, we have, let's see how much grams we should put this to be by. We'll say 25 grams. So to work out the moles, the mass divided by the RMM, that easy one, which is equal to 0.25 moles. Right? So 0.25 moles of calcium carbonate in 25 grams of it. 25 grams of calcium carbonate. Any questions so far? No questions. If no questions, we can move along. So let's move along. If you have no questions, feel free to ask. Just remember, as I said before, for more, like and follow the Instagram and Facebook page. Feel free to message the WhatsApp number for inquiries, to join the one-on-one sessions. Just remember, we have to beat this COVID, and we have to stay smart and stay on top of our game by the end of this. So let's continue. And also remember, wash your hands, social distance. So let's do our next example. Let's do a big one. Let's do the crystallization of copper sulfate. Right. So you're going to do copper sulfate crystallization. So we have CuSO4 with 5 water molecules attached to it. So this is the water of crystallization. So the RMM for this one is a little more tricky. So let's work it out, shall we? So the RMM right. So the RMM for copper, let's work it as, let's find out. RMM for copper is 63.5. Plus the RMM for sulfur is 32 plus, in brackets, 4 by 16 for oxygen plus we also have 5 water of crystallization. Let's just round the water up straight up to 18 one time. So we have 5 by 18. And this gives us 200. That's not going to write that up on top. We need the space. That gives us 249.5. You round up to 250. The mass, we'll put the mass as 75. Little m, well, 75 grams. So, to calculate the moles for this one now, we have 75 divided by 250 is equal to, let's work that out, 0.3 moles. So as you can see, the relationship between mass, moles, and equation. So let's do a little flip now, a flip session. Let's do a flip session. What if we wanted to find the mass? They gave us the moles, and we know the RMM. What if we wanted to find the mass? Well, let's just flip up this equation a little bit, because it's basically basic maths. So how the equation says, the equation says 4 moles, amount of moles is equal to, let's bring this up, amount of moles is equal to the mass of the substance in grams divided by the molar mass. Now if we were to switch up this equation now, it would now be, we're trying to get mass in grams, right? So we'd have amount in moles divided by, or should I say multiplied by, because we're bringing that across, by the RMM, and that would give us the mass in grams. So let's work an example here for this one. Let's do it for sulfuric acid. Yeah, let's find the mass for sulfuric acid. So we have H2SO4. So the RMM is equal to 2 by 1 plus 32 plus, in brackets, 4 by 16, because we have 4 oxygen atoms, 4 oxygen molecules, plus, and the mass of it is 16. So that would equal to, that's 2 plus 32 is 34, 34 plus 64, 34 plus 64 is 98. We'll put the moles as 0.5. So as the equation shows, to find the mass, we have 98 multiplied by 0.5. That now gives us, let's work it out, .49 grams. So we have 49 grams. Now that's an easy one. Let's do it for our next equation, shall we? So let's do our next example. I see all you chiming in. So let me see how they work this one then. So let's do our next one. We have, let me do it for, let's see. Let's do it for ammonium sulfate. Yes, we'll work it out for ammonium sulfate, which is, in brackets, NH4 by 2 sulfate, SO4. M equals, we have 14 for nitrogen, plus 4 for hydrogen, because it's 4 hydrogens we have, and 4 by 1, in brackets, 2. Right? We might want to move that 2 from there. Bring it forward. 2. Then we have plus, we have 32 for sulfur, plus 16 by 4. Let's see if we work that out. 132, that is correct. Correct. 132. We'll give the moles for this one as 2.5. What is the amount in grams? Mass equals what? Let me see if we can come up with an answer. $330 grams. Now let's see if that's true. So we have 132 multiplied by 2.5, and work it out, you do get 330 grams. Good job, good job. That's correct. Loving the answers, loving the answers. Alright. See all again, you hang on this thing. Let me just take it up a next level. Let me bounce back to finding moles then. Seeing that you all seem to grasp the concept of it. I see y'all, good job. Karen and good job. Let's try next one. We do a next one. We got to get this thing down. So we're working out for moles now. We're going bounce back into moles. So we have, we'll work it out for potassium carbonate. So we have the RMM equals, let's work this out again. Alright, let's go. Let's work this thing out. So we have 39 for potassium by 2 plus 12 plus 16 by 3. We have moles. No, not doing moles. We're doing mass now. We cannot do moles. We have the mass as mass (27.6). We call the moles. RMM 138. That's correct. Work out the moles. Anything? So we have 138 and we have so we have an answer. Let's check it out and see. That is correct. The answer is 0.2 moles. Good job, Karen. Good job. Good job. It's Keon. Sorry. Good job, Keon. Alright. So we'll do one more example to end it off. End of the session on moles and equations. And the next time we do comment on next live, most likely we'll be doing the next half of this, which is finding the concentrations and working it back. So let's do a last one. We can out our next one for grams this time. So you'll do magnesium sulfate in the crystallized form. So that's magnesium sulfate in the crystallized form, with water of crystallization attached to it being this. So the RMM equals, let's work that out. So the RMM for magnesium is 24. So it's 24 plus 32 plus 16 by 4 plus 7 by 18 for water. We have we're looking for mass this time. So our moles equals 0.25 find the mass. Yes, so see if we can work out that one. Right, that's correct. On 61.5 grams, that is also correct. Alright, so good job on that. So that basically covers on how to work out moles or finding the mass and how to calculate the relative molar mass. So let's just quickly review this. A mole of a substance. A mole is the mass of a substance containing the same number of fundamental units as there are atoms in exactly 12 grams of carbon-12. 1 mole is the amount of a substance that contains 6.02 by 10 to the 23rd particles, whether it be atoms, molecules, or formula units of a substance, which is also known as Avogadro's number. So, important things to take away again. 1 mole of any element equal to the relative atomic mass of that element in grams. Next thing to take away, in terms of molar volume, it is calculated in dm cube or cm cube, and if it's in cm cube, make sure the units match, and you're dividing by 24,000 cm cube or 24 dm cube if it's already set to dm cube. Then we have our triangle, formula triangle, which has working with mass, relative molar mass, and moles. Then we have what we've last reached, which is the amount of moles equals mass of a substance in grams divided by the molar mass. And then on top of that, if you want to calculate the amount in moles, to calculate moles, the grams, you multiply the amount of moles by the RMM, or relative molar mass. How we get the relative molar mass? There's a relative molar mass for each element in the compounds, and we just add them up and we get the relative molar mass. Right? So I would like to emphasize again, keep safe out there, COVID is real, stay inside, social distancing, wash your hands, proper hygiene, do not touch your face. For more, follow us on eTutorTT or Facebook page. Any inquiries, you can direct it to the WhatsApp messenger. And we'll leave it off for today. Thanks for tuning in. It was nice having class with y'all. We'll see you until the next time. See y'all. Take care, and remember, study those moles. Exams round the corner.